This is for Year 12 methods. It's sketching exponential functions. It comes from exercise 2.3. I'm going to draw an example out of question number 1 and question number 4. It was work that I covered while the swimming sports were on. Okay, question 1 says, state the transformations required to move y equals e to the x to this, and sketch the graph of the function. Okay, I've got a 2, a 2 and a 1, so therefore there's been 3 transformations. This 2 has an impact on the y, so I'm going to move that to the other side. Equals, these both are to do with x, so therefore I'm going to keep them there, but I need to isolate the dilation from the translation, so I'm going to have e to the 2 x plus 1/2. Now I'm going to use my replacing language to come up with the transformations. On the left hand side, y was replaced with y on 2, therefore that's a dilation by a factor of 2 from the x-axis. Notice the opposite. That was a half, so it's a dilation by 2. That was about y, so therefore it's from the x-axis. Here, x became 2x, so x was replaced with 2x. Therefore, the dilation is by a half from the y-axis. And the last bit, x was replaced with x plus 1/2, therefore that's a translation to the left 1/2 units. So there's my 3 transformations. 1, 2, 3 in that order. Now I need to draw it. Keeping in mind that my original graph was e to the power of x. So my original graph would have gone through at 1, had an asymptote at y equals 0. That was dilated by 2 from the x-axis, therefore all of it was doubled, and it would have looked like that. It was dilated a half from the y-axis, therefore that was moved into there, 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 therefore it's going to look like that. And then it was all moved to the left a half. So my point here, which is 1, went up to 2, stayed where it was, then got moved over a half unit. Therefore, my asymptote is still going to be at y equals 0, but my point, which was here, has now moved up to 2 and gone over to a half. So it's going to look like that, and that coordinate is going to be at negative a half and 2. There is no x-intercept because the x-axis is an asymptote, and I can work out what that point there is by substituting 0 into the equation. The equation is y of 0, and it's going to equal 2e to the 0 plus 1, which is going to be 2e. So that's 0 and 2e. I've got my second point labelled. That's y, that's x, and that's what the graph will look like. The second question I'd like to do out of this, it comes from 4b. And in 4b I need to sketch the graph, write the exact x and y intercepts. I'd like to work out what transformations have occurred. I can see the 2, the negative, the 5 and the 6. So 4 transformations have occurred. the 2 and the negative and the 5 are all about x. This 6 is about y. So I'm going to move the 6 and have it 6y minus 6 equals 10. I need to isolate the negative 5, which is the reflection and the dilation first. So that will become x minus 2/5. Here is my dilation, the 5. X has become 5x, therefore a dilation by a factor of 1/5 from the y-axis. X has become minus x, therefore a reflection over the y-axis. X has become x minus 2/5, therefore a translation right 2/5. And y has been replaced by y minus 6, therefore a translation up 6. They're my 4 transformations that have occurred. Normally, the logarithm graph, the exponential graph, would look like that, going through at 1. This point here, 1, dilated 1/5 from the x-axis, the y-axis, stays where it is. Reflected over the y-axis, stays where it is. To the right, 2/5 up 6, it goes up there to 2/5 and 6. The dilation 1/5 from the y-axis makes it skinnier. The reflection over the y-axis makes it go like that. The translation. I would expect my graph to be up here, and it's going to have an asymptote, which is y equals 6. And I should have a point here, which is 2/5 and 7. That should have been 7 because it started at 1 and went up 6. So I'm not going to have an x-intercept in this particular case, but I will have a y-intercept. And how would I be able to work out the y-intercept? Y of 0 will equal 10 to the 2 plus 6, 100 plus 6, 106 is going to be my y-intercept. So my scale is massively incorrect, and that if I was to draw it again, I would need to if that was an asymptote there at 6, and that up there was 106, and that is going to be 2/5 and 7. So I've got my y-intercept, I've got a second point, I have my equation of y equals 6.